Okay, let's talk about whole number exponents. So some basics. If z, let z be any complex number, n be the number of factors, or any positive integer, and then that would be the number of factors of z. So the expression zn is defined to be the product of z's with n factors. Z is the base, n is the exponent. I tell students that the rules for exponents are just shortcuts. You don't need to know the rules you don't need to do the shortcuts till you understand the rules. If they forget the rules, they can always go back to the definition. That definition right there. X squared times x cubed is x times x times x times x times x. If I have x squared cubed, that is x squared times x squared times x squared, or x times x times x times x times x times x. X to the fifth divided by x to the seventh, that is 5 little x's over 7 little x's. The sets of x's filter off to 1. And again, xy cubed is xy times xy times xy. And we can group that however we need to if we're dealing with the real numbers. This is a good place to start. So we're going to look at the power functions. So f of z, where z to the power of n. Even when looking at more complex polynomials, even degrees smile or frown if they're negative. Right? So each of these are an even degree. And really what happens is how long they seem to sit at 0. Doesn't matter the degree. If it's even, this is going to be the pattern. And it smiles when it's positive, and it frowns when it's negative, when our leading term is. Odd degrees, right? So here we have a line. We have something close to a cubic, something close to a quintic. But in general, this is the pattern. So this, because they're kind of rising on the right, falling on the left, these are positive. They would flip if they were negative. So rise on the left, fall on the right if they're negative. So consider the graphs y equals x to the fourth and y equals x to the sixth. X is a real variable, a real number. At what value of x do the graphs intersect? On what interval is x to the power of 4 greater than x to the power of 6? And on what interval is x to the power of 6 greater than x to the power of 4? Give convincing explanations for your argument. Well, pretty straightforward. If I want to know where these intersect graphically, I can draw them, but the reality is that these are probably not going to show up very well. My guess is the intersection happens at a very low number. So let's just kind of, in general, let's look at this piece and let's figure out, how do we solve this? How do we solve this for any properties? So first thing I would do would be to say x to the power of 4 equal x to the power of 6. Just because I don't want to deal with a negative, I'm going to go ahead and minus x to the power of 4 and minus x to the power of 4. Now 0 is equal to x to the power of 6 minus x to the power of 4, which is equivalent to x to the power of 4 times x squared minus 1. Well, That means that's not crossing very well. X to the power of 4. Wow, that's not doing very well. Okay, let's do it over here. X to the power of 4 is equal to 0. It means the factor of this, which would be x plus 1, is equal to 0, and x minus 1 equals 0. That's a difference of squares. So here, x equals 0, x equals -1, and x equals 1. So I intersect this graph, these two graphs here, intersect at x equals -1, 0, and 1. And I have to have an understanding of numbers to actually answer the next part, right? Because if you don't really understand numbers, you don't know what happens. So let's take that. We do understand numbers, so let's figure this out. Where is the higher degree going to give us a smaller number? This says, at what values, when I raise powers, do I get a smaller number? So we need to have, like I said, some kind of understanding. So let's think about this. Powers of fractions let's be clear, of real numbers, right? Of real numbers less than 1 get smaller. Right? So if I have 1 to any power is 1, nothing changes. But if I have a number less than 1 and I raise it to a power, think a half maybe. That's easy. A half. If I raise that and I square that, I get a fourth. That's smaller than a half. So I keep going down, and that's kind of the process. And then the other piece would be the reverse of this, right? Powers real numbers greater than 1, right? Greater than 1 get larger. So how do we write that out? We may write that out with something that says, right, because that's the way the question was worded, so we'll focus on the first part. X to the 4th greater than x to the 6th. And we could include, yeah, okay, let's do that. So let me think. So here, x is an element of -1 to 0. 0 is an intersection, right? So we don't want a union with 0 to 1. And something that says here, the absolute value of x must be less than 1. Okay, and then we can say that it's going to be the other way around, right? X to the 4th is less than x to the 6th when x is an element between, and we'll also talk about absolute value. We'll do that then. So negative infinity to negative 1, union 1 to infinity. Here, absolute value of x is greater than 1. So we intersect at 0. We intersect at negative 1 or 1, depending upon which direction we're looking at going. And this is giving a very solid explanation of why we're putting these as answers. And that's the important part, right? We want to make sure we're doing this right. We want to make sure we're explaining in a way that our students will understand. This is not about, remember, this has never been about whether or not you can do it. I assume you're in this class and studying, becoming a teacher of mathematics because you can do the calculation. But calculation is really not the math. Mathematics is explaining, it's understanding numbers. So now let's generalize the last exercise to graphs of y equals x to the n and y equals x to the m, where m and n are just positive integers. Well, we have to be very careful, right? We know they're positive integers, but we don't know if they're both odd. Are they both even? Is one odd, one even? What happens? So we need to figure this out. And let's do some work here. So we're gonna, so this was number 10, and we're supposing that x to the power of m is equal x to the power of n. Where n is going to be greater than m. And I'm just using the alphabet, right? You get to m before you get to n, so n is greater. And we have this from before, but m and n are elements of the positive integers, right? So they're positive integers. So then we can do, like, so this is true, then we can factor that to be x of m, x of n minus m minus 1 equal to 0, right? And then we have to consider, well, what happens? And we'll need to be specific, right? We're going to have to state some facts, but just in general, what happens? We have that if m and n are both even or odd, even or both odd, right? Let's be clear. Then there's 2 between each one, right? If they're both even, then the difference between 2 and 4 is 2. The difference between 4 and 6 is 2. The difference between any two even numbers is 2. The difference between any two odd numbers is also 2. 3 and 5 has a difference of 2. 5 and 7, difference of 2. 13 and 11, difference of 2. So they all have a difference of 2. So if they are, then their graphs we'll always create like the previous example, so we will always have intersection. The graphs will intersect at x equals -1, 0, and 1. If only one of them's odd, doesn't really matter which one, so then period. If only one m or n is odd, the graphs intersect at they would intersect at 0 and 1, right? So only one of them are, the other one's negative. So intersect at x equals 0, 1. All right. So then we need to define these cases we just listed there. So let's start with the easy ones, right? The top ones. We're going to start with those top ones because they're fairly straightforward. So case 1. Case 1. M and n are even. Bam. So then x of m greater than x of n when x is an element of -1 to 0 union 0 to 1. Basically, I'm putting down what I had above. And x of m less than x of n. This happens when x is an element in the interval -infinity to -1 union 1 to infinity. Great. Well, we kind of have the reverse for the odd, so let's jot that down. So case 2. M and n are odd. Right? So here we're saying they're odd. Then x of m greater than x of n when x is an element from, right? So here the smaller one is bigger, but these are odd. They are separated by 2, so we expect the 2 results. But in this case, we have to think about this. The x could be any real number. Okay, so if they're both odd and you plug in a negative number, you get out a negative number. These are true statements, okay? So we need to keep these in track. So then this one, and consider it for yourself. I mean, I want to make sure you guys understand these enough. You have to understand these. You're going to be explaining these and teaching these. And if you don't understand it well enough, well, then you won't be teaching it well. -infinity to -1 and union. And because when it's actually, remember, m is the smaller number, smaller power, so it's a smaller integer. Maybe it's 3 and the other one's 5, something like that, okay? So if I plug in a large negative number, I'm going to get out a bigger negative number. which will be smaller than the negative number I put in. If you plug in -2 and you raise it to the third power, you get -8, which is a smaller number. And then this also happens between 0 and 1. And then m this time is less than, so the smaller number is less than, smaller degree is less than the larger degree when x is in the element, well, between -1 and 1, -1 and 0, I mean, right, because we're plugging in a smaller value, so we would get a smaller negative number, which would be bigger because it's negative. It'd be a larger value, and this would union with 1 to infinity. And these I feel are pretty straightforward. We have to be careful when we talk about the odd ones. So this is going to be case 3 and 4. We'll choose which one's which and kind of go from there. So case 3, I'm going to say m, the smaller power, is even, and we'll say n is odd. The larger power is odd. So again, x is going to be greater than, the smaller power is going to be a larger value when, well, when we plug in a negative value, right? X is an element from -infinity to 0. It would hold true there, and it would hold true between 0 and 1. It would be the smaller value, the smaller degree would have a smaller value from 1 to infinity. So 1 to infinity. Then we have case 4. And this one is going to be the other. So m is odd and n is even. So then the smaller degree is going to be greater. Now we do need to remember this one is negative. M is odd, so that means if I plug a negative value in, it's going to become a smaller number. So that's not going to be the one we want, smaller value. So we're really only looking at this happening when we deal with a small number, when they're both small numbers between 0 and 1. Then the higher degree is going to become smaller than the lower degree. And so we have that this is true between 0 and 1. And this is going to be true when x is an element -infinity all the way to 0. And if you think about that, I plug a -2 in, my odd degree is going to keep that value negative. Here on this one, it's a even degree, so it will become positive and is automatically going to become higher. For any negative I plug in, it's also going to be true from 1 to infinity. Okay, that answers that question. Clearly stating it, and how did they tell us anything? Generalized exercise to the graphs of y equals x of n and y equals x of m. M and n are positive integers. So we just generalized it. We didn't graph it. We could graph them, but it would be real difficult in this case because this is a general statement. But this statement is true based on what m and n are. So, and we've taken care of every case. So whatever m and n are, we are good. And we explained what's going to happen graphically, which one's going to be above the other, right? Because each one of these statements is staying between this value. X of m will be less than, it will be a lower y value than x of n. And it will also be true here, just not here. So we've given everything, and we're good to go. All right. Keep working on them. Have a good day.